Good afternoon. We're going to spend the first 8 to 10 minutes. I'm going to go through a script for you, talking a little bit about the Gulf of Mexico, why it's important in our lives and how we affect it. And then after that, I'm going to answer questions that you have about red tide, and I'll be happy to do that. So again, I'm Sandy Gilbert. I'm the chairman of START. I work there with Mr. Childs, who you all know is a part of a grassroots organization. We work with scientists, government, and economically and environmentally responsible businesses to help try to preserve our coastal waters. That's basically what we do, and we do tend to specialize in red tide because it's such a severe problem. So let me go into this little talk about the Gulf of Mexico. The Gulf of Mexico plays a major role in our everyday life, from our climate and daily weather patterns to the food we eat and our casual outdoor lifestyle. At about the size of Alaska, the Gulf is the 9th largest body of water in the world. It is about half the size of the Mediterranean Sea. It is linked to the Atlantic Ocean by the Florida Strait and connected to the Caribbean Sea through the Yucatan Strait. The Gulf receives fresh water from 150 rivers in the United States, which accounts for 31 of our 50 states. That's how it's fed. Get that again. 150 rivers find their way to the Gulf of Mexico. Water exiting the Gulf forms the Gulf Stream in the Atlantic, which moves, here's some more statistics I don't think you'll know, moves 100 times more water than all the rivers in the world combined. And it flows 300 times faster than the Amazon River, the largest river in the world. It's quite a unique body of water. Though relatively shallow for a large body of water, it averages only 5,000 feet compared to the ocean, open ocean, at 12,000 feet. One section of the Gulf near the Yucatan Peninsula, called the Sigsbee Deep, drops to 12,000 feet and expands for 300 miles. You certainly realize the Gulf of Mexico is a resource that's very important to us. But did you know that the Gulf accounts for over 25% of all U.S. seafood every year, totaling $900 million annually? Of course, the reason for this valuable bounty is the Gulf's great biodiversity in sea life, ranging from plankton, some of the smallest life in the sea, to whale sharks, the largest fish in the sea, measuring up to 40 feet long and weighing 80,000 pounds. In fact, back in 2009, scientists measured over 15,000 different species of marine life that live in the Gulf of Mexico, including small invertebrates like jellyfish, a wide variety of coral, and some of our favorite fish like bluefin tuna. And the Gulf coastal waters near here where we live are especially important, with its cordgrass, seagrass, and mangroves where the sea meets the land that serves as sanctuaries that feed and protect many forms of sea life, including even many deep sea species like tarpon. The Gulf is also a major source of petroleum energy. With 304 active oil rigs, it produces 17% of the U.S.'s total crude oil. And the Gulf Coast is a major tourism destination, generating $20 billion annually in tourism expenditures. But the Gulf as we know it is being threatened by a number of man-made activities. An obvious example, the BP Deepwater Horizon oil spill in April of 2010 gushed over 5 million barrels or 210 million gallons of crude oil into the Gulf for over 80 days. To put that in perspective, that's 19 times larger than the Exxon Valdez spill in Alaska and Prince William Sound back in '89. And while some of the effects of the BP oil spill are very evident, it will take many years before scientists really understand and can determine the full impact on the Gulf ecosystem. And unfortunately, the negative impacts on our marine environment of our overdependence on fossil fuels is not limited to occasional energy-producing mishaps. It is a daily occurrence through airborne pollution from fossil fuel burning automobiles, power plants, and industry. Since the Industrial Revolution, some 200 years ago, when factories first began putting out extensive amounts of carbon dioxide into the atmosphere, the pH, or acidity, of the ocean water on the Earth has increased by 30%. When the ocean becomes more acidic from the discharges from automobiles, power plants, the amount of carbonate ions decreases. And many species, like coral, with skeletons made of calcium carbonate, and various types of plankton are threatened because they can't grow their protective shells. Since these species form the base of the marine food chain, their plight affects many species beyond their range, like the very grouper that we depend on as a food source. Beyond the negative impact of airborne pollutants, the Gulf is also seriously threatened by polluted runoff. Again, remember 150 rivers from 31 different states wind their way to the Gulf, bringing fertilizers and pesticides from agriculture and some oil and gas residue from automobiles that continually flow into the Gulf. At its worst, this process creates hypoxia, or a dead zone, like the extensive area south of the Mississippi River, where reportedly stretches now 8,500 miles, the size of the state of New Jersey. When I first started giving this talk 3 or 4 years ago, that site was the size of the state of Rhode Island. So in just that amount of time, there's a big difference between the size of Rhode Island and New Jersey. At the worst, this process, I already did that. On our misuse of precious Gulf resources doesn't end with man-made pollutants or runoff. Although plastic can be recycled, it is estimated that only 25% of all the plastics recycled in the world gets to be recycled. The rest ends up in litter or in landfills. And unfortunately, huge amounts of plastic end up in the world's oceans, where the currents drive them together and pile them up in concentrated areas like the Pacific Gyre, where samples contain, get this statistic, samples of water from the Pacific Gyre contain 6 times more plastic than plankton. That's quite something. This is a major problem for sea life because plastic decomposes very slowly. For example, a plastic bag in direct sunlight takes 50 years to completely decompose, and a plastic container takes 500 to 1,000 years to completely break down. In the process of slowly decomposing, plastic breaks down into small particles scientists call nurdles, which closely resemble sea organisms like plankton and jellyfish. These nurdles can be mistakenly consumed by unsuspecting sea turtles, seabirds, and other marine animals that they cannot digest, and leads them either to malnutrition or starving. The picture of this dead seabird was found in the North Pacific Gyre. It had 1,600 pieces of plastic in its stomach. As if the foregoing isn't enough of a challenge, the Gulf needs to contend with some other issues that are stressing its health and its biodiversity, and one of those is overfishing. Overfishing with long lines and other maximum yield techniques have eliminated nearly 90% of our large fish species like tuna and swordfish. 90% from back in the 50s, 60s. A long line can stretch for 50 miles, and it can catch fish in large numbers so fast that they can't replenish their stock. Mass catch fishing methods like trawling also snare a large amount of bycatch, something other than what they were fishing for. In fact, 90% of the catch on shrimp trawlers is something else, or bycatch. This is why it's necessary to have fishing seasons for certain species and even fishing bans to try to preserve some of the overfished stock like the grouper shown in this sandwich. In short then, human activity is threatening our Gulf environment in two different fundamental ways. Number one, we're putting too much polluted material into the Gulf through airborne pollution, polluted runoff from rivers, and plastic and other refuse. Number two, we're taking too much sea life out of the Gulf by overfishing or too much bycatch. Well, hearing all of this, what does this mean to you, or more importantly, what can you do about all this? Actually, can do quite a bit because of become a Gulf ambassador and learn how some small, subtle changes in your own personal habits and lifestyle can help counterbalance some of these trends that I've been talking about. For example, you can help air pollution by reducing ocean acidification by simply turning off the lights and the TV when you leave the room. Less work by the power plant. Lower your air conditioning and use available ceiling fans. When you can, save gasoline. That affects the situation. You can also control harmful runoff by reducing the flow of unwanted human waste materials into the Gulf, by being more careful about what you flush down your toilet. Are you flushing drugs and chemicals down your toilet? Don't do that. And of course, as our county has projected for some time, don't fertilize in the rainy season. Better water conservation can also be a big help by reducing polluted runoff. For example, make sure you use less water because less water means less runoff. Don't irrigate your lawn during or after a rain. How many times I drive up the Keys and I see someone who's got their sprinkler on without a range gauge. They might live in Ohio, but it's watering and it's raining. We don't need to do that. Check your toilets regularly for flapper valve leaks. Take shorter showers. Start work with the town of Longboat Key because they have to buy water from Manatee County, and they had to pay a $500,000 premium in 1 year because they were buying too much water, most of it going on lawns. So they put a program, and we worked with them, teaching people these things I just talked about, and they, as a town, not a condo, not a house, an entire town, in 1 year used 33% less water. These are simple things in your lifestyle you can do that aren't prohibitive or terribly costly. You can also reduce the amount of disposable plastic that you use in your life. Use reusable water bottles. Recycle the ones that you do use. Don't take plastic bags from the supermarket or other retail stores. Bring your own carry bag. That's easy to do. And you can also help, which probably will sound surprising to you, what can I do about overfishing? You can choose the fish you eat to create the market demand for it. Follow our guidelines for sustainable seafood. When you buy seafood, when you go to a restaurant, order seafood that's sustainable. Eat less grouper, swordfish, and other overfished species. Instead, choose mahi-mahi. Taste is very similar, and it's not a threatened fish. And you can also, of course, if you're interested, to join us. Here's some of the things that START does to help protect the marine environment. We, of course, have education courses and things like I'm doing today. We have the materials I have down here we give to school children to teach them about red tide and the environment and how to protect it. We work with the Sarasota Bay Watch and their new clam seeding program in Sarasota Bay. That helps clean the bay. Those clams are less susceptible to red tide. They're a very key chain in the food chain, and they've been disappeared for years. We're putting them back. And of course, you may have seen our videos on TV, our PSAs, where we warn you, watch out, a red tide is coming. And we support MOTE's Beach Conditions Report, which tells you There's red tide at this beach, but if you go 6 miles down the road, it's not there. So that's what we do. That's what you can do. That's generally about the Gulf, but some of you, of course, are here about the red tide situation. Let me just ask you, what do you want to discuss or ask me about red tide? I'll be happy to discuss it with you. Any questions about red tide? Yes, sir.
The results that they get on red tide analysis, by the time it gets diagnosed and printed out, is it still usable for a swimmer? In other words, like if they tell you that this beach is okay, by the time you receive this information, from what I understand, this red tide moves very quickly. Is it possible by the time you get this information and go into the water that that number could have changed?
Could you restate the question?
How accurate is the red tide prediction data? It's actually very accurate, and it depends only a little on where and how you get it. If you go to a phone app at Moat, it's taken twice a day, morning and afternoon. It's damn accurate. It moves fast, but it doesn't go from Coquina Beach down to Longboat Key in anything close to a day. So the net effect is if you get it online or on your phone, it's today's stuff. It can't be more accurate. If you were looking on reports that NOAA or someone else sends out monthly or something like that, obviously it's less accurate. But the key is you're getting literally a 10 o'clock and a 2 o'clock read here, part of which START helps fund and Moat funds the rest of it. So you should know, just check it out. And I can't go to Coquina Beach, but I can pop up here to Anna Maria and I'm okay.
So the test doesn't take, it's not like a bacteria test that takes 24 hours, it's a shorter turnover?
No, it's a quick cell count that Moat picks up and looks at. It's done by lifeguards and public officials in Manatee County, but they don't analyze it. Although when you pick it up and it's all green, you don't have to be a scientist to know. And also the air, the toxins in the air will just tell you. I can walk out on a beach and I don't need a count. I know I don't want to be here, or I do. You probably do too. But it is a great service because they're now using satellites and they're using a bunch of technology to get the information to you quicker.
So it travels like a plume?
Red tide is it's not red, it's more of a brownish green. It floats. It's not just K. brevis or red tide cells, it's a living ecosystem because in it are other critters the red tide eats. There are other critters in there that eventually absorb all the toxins and red tide goes away. Most people ask me why it starts, and that's sort of been pretty well documented. I always say, don't ask me why it starts. Ask me why it stops. It's not because I'm giving a great speech or the Florida government has put a lot of money into finding a cure. The answer is things in nature happen that eventually goes away. And one of those things is there are organisms similar to red tide, other dinoflagellates, little microscopic stuff, that begin to absorb the toxin. There's also an enzyme called cysteine that's a natural enzyme in the water in the Gulf of Mexico and most oceans. It has a factor of absorbing the toxins and over time reducing their impact where fish and other animals begin not to die. And so that's kind of what happens. But anything else I can answer, either you or anyone else? Go ahead, sure.
Is the odor caused by endotoxins inside the cell?
There are about 5 of them they look at. They think there are 13 to 15 that actually exist. A mix, it's a true soup of stuff that the organism basically uses to kill its prey and consume it. But it has a very thin cell structure cell. And when it gets into the waves in here, they break up and in effect die, but they release all the darn toxin. You might not smell it as much out on the water in a slack situation. When you're on the beach and waves are breaking and red tide cells are crashing into the sand and shallower water, they break apart and they release the toxin in the water. They're not eating anything in the air. But when they break up, it goes into the air, and that's what bothers all of us and gives us a stuffy nose or itchy eyes. So And do you all know about eating during red tides, what you can or can't eat? Do you all know? You don't know that. The state of Florida spends a fair amount of money through the Department of Health, who we work with and part of the Red Tide Alliance to test all the seafood that goes to Ed and other restaurants and to Publix. And they spot test this and look for toxin levels, and if it's ever of a certain type, that species, a certain height, that species, that piece of fish, whatever, doesn't go to those markets. So you can eat things during a red tide bloom in a restaurant, and you can buy them from Publix. What you don't want to do is eat the shellfish that your neighbor picked up in the bay and says, I got some great clams or whatever for you. The reason is why. Shellfish are what? Filter feeders. And when you eat a shellfish, it isn't like eating grouper. You don't eat the guts of grouper, you eat the fillets, which you probably can do if it's not too high a red tide. But a shellfish, an oyster, a clam, you eat the whole thing. And it's a filter feeder. It's part of the reason red tide eventually goes away. The ones it doesn't kill or make toxic, eventually they spew it out. But you don't want to eat it until they've gotten rid of enough of it so it's not toxic to you. You notice red tide because of the air, smelling and feeling. But actually the greatest danger to it is in your stomach. That's why you've really got to be careful. Now, no one's died in Florida in over 30 years. And they don't die from inhaling it per se. They die from eating it, and it becomes just a nasty gastro thing, and it can kill you because of the toxins. So that's why you're careful what you eat it in the right places, but the state of Florida has put a fair amount of resources into be ensuring that you're pretty safe and can eat these things. Yes?
Is there any evidence that fish and other wildlife are becoming resistant to red tide or getting
Some species, yes. One of the reasons we started working with the Sarasota Baywatch planting scallops in Sarasota Bay. They're a very cute animal. They got all those blue eyes. They used to be here, and even though Sarasota Bay is improved in the last, one of the few estuaries in the United States, but it's only gone from a rating of 3 to 5 on a scale of 10. So it's still not as clean as we would like. But scallops are like canaries in a coal mine for red tide. They roll over real quickly. And they only live 1 year. So what the Baywatch and we are doing is switching to southern quahog clams. They also naturally lived here years ago. There aren't many. We're planting them because they have three added advantages over scallops. One, they live longer, not 1 year. So it's hard to keep a colony going. They live for 20 years. Second of all, they're much, much more, what's the word I'm looking for? They're much more resistant to red tide. It doesn't bother them as much. And third of all, they burrow into the ground, creating better growth for seagrass. So the clam is a huge, and of course it's part of the food chain. So you're going to have more fish because until they get older, the clams can be eaten. So that's one of the reasons we've switched to clams, because that particular type is resistant to red tide and has these other benefits. But in general, I don't think you can say grouper and other fish, and certainly not mammals like manatees, have developed any great degree of defense against red tide. It messes them up badly. Yeah. Anything else, folks? Oh, yes, sir.
Is the occurrence of red tide, is it the same? Is it increasing, decreasing? What are the longer term?
There are several groups of thinking on that. Some say not really. Some say yes. I'm in the yes group. And there are some, by that I mean scientists. And I think there are people studying it now, and we believe it is at very least lasting longer. I used to ask people to donate to help us fight red tide all in the season, and they live in Wisconsin. They say, I hear it's terrible, but they go home. They never saw it. Now it's stretching into now, past the fall, and into parts of the season. So I know people politically in the governments here that are taking red tide much more seriously. Not so much that we get more blooms, but the darn blooms are lasting longer and working into the tourism system, which certainly Ed can tell you what happens when you have a bloom outside his restaurant. It's a huge thing. So I think the consensus is coming to and will eventually say, yeah, it's lasting longer, and we got to really keep looking at ways to possibly deal with it.
So why do you think it's lasting longer?
A variety of reasons, but one of the things that's starting to come out in a few scientific circles is that they've always talked about nutrients being the big issue, and it's certain you have to have something to eat, so yes, nutrients important, except people are starting to see that there's a correlation between salinity of the water and the temperature of the water. And what has happened in our warmer weather, I've been here 17 years. It's definitely warmer here now than when I first came. I mean, I can see it in the plants that grow in my yard. I can see it no argument, it's warmer. And what seems to be happening is the temperature in Sarasota Bay or the Gulf is not necessarily on average hotter than it was X years ago, but the amount of cold swings from the north and the amount of cold, real cold nights has dropped. So while the average is not much different, the number of cold nights is way down, way down. And that's, of course, what? One of the factors that drives away red tide. The cold weather comes and we don't have it. So temperature of water is really being studied, and so is salinity. There seems to be a big correlation. When you get to X number of salinity, it loves it. If it drops and it's too much fresh water, it doesn't do well. If it goes up above this amount, oops, too salty, it doesn't reproduce, it kind of goes away. So these are two new things we're trying to look at that might have an effect on what it is. Not that necessarily we can control them, but at least we might be able to predict that it's coming. But it definitely, to most people, the perception is it's here longer than it has been in the past. Yes?
Have you heard of any other research concerning treatment of the red tide in the water? Like if there's anything they can do to try to kill it, or do they worry about too much of that? They wouldn't know how it affected that.
That's always a concern. I'm not ready to talk about it at great length. Let's just say I'm working with a company that's had very good results eliminating the green algae that plagued the east coast of Florida last summer. It's not red tide, but it was much, much more dense and toxic than red tide. It was from the release of the water in Lake Okeechobee that went into the rivers. And they went in there with this rather strong process that got rid of it in a number of days. And we are working with them, Moat and Florida Fish and Wildlife, in an experiment at Moat that I'm right now in the middle of trying to fund, to see how we can use it on red tide, at what levels. It wouldn't be as strong as the amount used over in Jensen Beach, and how long the water would be in a state, if it is, that yes, it's killed the red tide, but what's the collateral damage? START will never support anything, even if it kills red tide, that has environmental collateral damage, okay? So that's our task. We know things already that'll kill it. The problem is it kills everything else. What I like about this process that this company is using, they've used it in Mississippi near the Biloxi hurricane to take drinking water that was fouled by the hurricane, swamp water pulled into the water source, and people today are drinking that water. So I'm saying if that process or some version of it can make water that people can drink, I'm hoping we can get this water such that it can go back into the environment and not be any more dangerous than the normal water in that body. It's preliminary, but I'm very excited about the prospects of it. Anything else? Thank you.
Next up, we have Karen Willey from Around the Bend Nature Tours.
Okay, well, hello. I'm Karen Willey with Around the Bend. Around the Bend Nature Tours is an environmental education company. We started 18 years ago providing eco tours, and that didn't go as planned. There weren't as many people wanting to go walking in the woods as I thought. So I started doing environmental education, and we get grants from different agencies. We have a contract with Sarasota Bay Estuary to provide their education and outreach, And we now have impacted this year 10,000 students just this year, so pretty exciting. So I'm also a certified climate change interpreter. I was certified in 2013 by the National Network of Ocean and Climate Change Interpretation. So I want to share some of the latest info on climate change. And we're also going to move into sea level rise as part of that. So we got to start with climate change. You have to start with weather. Weather is what's going on outside the window. It's 95 degrees, it feels like 105, it's very humid. So that's the weather. And climate then is the long-term average. So it's weather over time and over space. So big regional areas or global. And so when we talk about climate change, it's a change in weather conditions. So global temperature, precipitation, other weather patterns, and there are multiple causes of this. Some of it changes because of natural variability, but the great majority is due to human. So global warming is the term we used first. And after realizing that it's more than just temperature, it's also weather patterns and other things, which I will get into. So global warming is now considered climate change. But this is the way global warming was first explained, and it was due to the greenhouse effect, which means that the carbon dioxide, which is there are several greenhouse gases. Carbon dioxide and methane are the two main ones. And when we burn fossil fuels, we create this, the carbon dioxide becomes trapped. It creates a heat trapping blanket. Let's see. Oh, this is not. So it actually creates a heat trapping blanket around the Earth. So we're burning fossil fuels, coal, oil, and gas. We are releasing carbon dioxide into the atmosphere, which creates this blanket around the Earth. So when the sun comes in, it gets trapped by the blanket. Just like when you go under the covers at night, it's cool, and then it warms up because your body heat warms it up. Well, that sun's heat that is not able to reflect warms up the Earth. So that's why our temperatures are rising. Pretty basic. And these are the major greenhouse gases. So you can see that 75% is carbon dioxide. The blue, the light blue shows, or the carbon dioxide, 65% is determined to be from fossil fuel burning. And then another 11% from natural causes. And then methane is another big one. So these are the gases that trap. All right, this is cool. I'm going to play this video, and they're going to show you what the carbon dioxide does over a year. Okay, so what this was going to show, yeah, I can play it at the end. What this shows is carbon dioxide changes over the year. And this takes us on a year in 2006 from January 1st to December 31st. And the yellow turns to red in the northern hemisphere, and then when trees leaf out in the temperate zone, and we have a lot more carbon being absorbed. So during the summer months, there's less carbon being emitted into the air because trees are a really good carbon sink. So I'll try and show that at the end because it's really dramatic, and it shows. And then in the southern hemisphere, they start burning things in the winter. I mean in the summer, because that's their winter. And so they're actually putting out carbon monoxide in the southern hemisphere. So it's okay. So this is the famous Keeling Curve, and it shows carbon dioxide monthly averages from 1960 to 2010. And the black line fluctuating is seasonal variations due to leafing and such. The red line is just the average. Okay, so notice the top, it's at 390. That's parts per million of carbon dioxide. And if you remember, a couple years ago, there was a group, and you probably know the group, it's 350.org. And that 350.org comes from the number of 350 parts per million, because they were concerned when we hit 350, that was going to be a big deal. And we hit that around 2000. So here is the next segment. This is from 2012 to 2017. So this is current. And you can see it starts above 390 already at 2012. We don't get anywhere, and we are all the way up to almost 405. So, and you can see the seasonal, the red line there is the seasonal variation based on leafing out, okay. So this is another way of looking at it. The carbon dioxide is at 400 parts per million in November of 2016. Now look at that green line where the 400 is. And we're going to go to current, and now we're at 406. Okay, so, and look at last year in September, October, we didn't even get below 400 parts per million of carbon dioxide. All right, now we're going to look at temperature. These are the 10 hottest years since 1880. And look at, they've all been since 1998. Now I'm going to go and show you, this was 2015, look at last year. It's pretty dramatic, and I'm going to go back so you can see. Dropping 1 year, look at that. So we are getting warmer, and this is real. All right, I'm hoping this is going to run. I think this will, yes. All right, so this is showing the temperature from a normal range and how it's changed. On the right are record year temperature years. And so that is the difference from an average. See, the average was 1980 to 2015. So the blues are from the 1880s, and those were pretty low, below average, and then now we're really up high. So we are at quite a dramatic temperature change. This is Arctic ice loss. Look at the red line. That was an average in 1979. And so we have 2003 on the left and 1979 on the left, which was almost full, and then 2003 on the right. And the same thing with 2012. This was the record low amount of ice in the Arctic was in 2012. And then this is 2016. It tied 2007. It's the second lowest amount of ice, and that was last year. So I don't know what's happening this year. But we are losing rapid loss of ice. So all this air temperature being warmer, the air and water want to come to equilibrium. It's basic science. So when the water is cooler, then the warm air is going to warm the water. When the water, then in the wintertime, the water's warmer, it's going to warm the air. That's the equilibrium process. All right, so the effects of rising water temperatures affect all of these things. Warmer water means warmer air. We're getting greater flood risk, rising sea levels, shifting seasons. I'm going to go over all of these briefly. So, of course, we know about sea level rise. The shifting seasons, the status of spring. So trees and spring wildflowers are blooming earlier than usual, and the winters are shorter. So this graph shows how how early spring was. So the red is early spring, and the blue is a late spring arrival in the continental United States this year. So it's coming, all of the eastern United States pretty much was early spring. And that affects migrations. So we're also seeing stronger storms. This is Chicago last week, 2 weeks ago. They had record flooding and 7 inches of rain in 2 days. And we're seeing more and more of these record storms. We're seeing 100-year floods and 200-year floods in really short proximity. I was at a talk given by the Florida Wildlife Corridor a few months ago, and they said that a big area like Sarasota Bay needs 5 years to recover from one of these big events, and we're not getting that 5 years of recovery in between anymore. These things are happening more and more frequently, and that's due to the increase in air temperature. Another Another issue is ocean acidification, and it's a very, very complex chain of events. But when the carbon dioxide, because that also wants to come to equilibrium, it's entering the oceans, and it forms carbonic acid, and there's free hydrogen out there that is taking up, how does this work? So the free carbon is not allowing the carbonate to be available to the animals, and then their shells. They're having issues with their shells. Okay, they can't make shells. And so the biggest issue is with the plankton. It's at the bottom of the food chain. These plankton that are forming calcium carbonate shells are not able to do that, and they're dying. And that's the basis of our food chain. So it's affecting fisheries throughout the world. Okay, this is another one in motion. Is this going to show me? Yes, we're going to link to YouTube. And this is showing animal migration. So you can see the mammals are, so this is where they're tending to go based on land mass that is in their way. So this is where the animals are going to go. The birds can fly, but they still follow certain flyways, amphibians and mammals. So it just, this was done by the Nature Conservancy, and it's pretty recent, and they took a lot of data and put it in an electronic flow chart. So I just thought that was really fascinating. So I'm going to close that so we don't go to the next one. I'll go back there. All right, so let's switch. So we have sea level rise due to rising temperatures. And now we're going to talk about how that's affecting our mangroves. So we all know about mangroves. They're found on our bayside beaches. In just the last decade, 35% of the world's mangroves have been destroyed. That's all over the world. This is a Smithsonian statistic. But the Sarasota Bay Estuary Program says over the last century, we in Sarasota Bay have lost 44% of our mangroves. That's almost half. And a lot of that is due to building seawalls. Yeah, building seawalls. So, mangrove forests, why are they important? They're food and nesting for birds and other wildlife, invertebrates. They also, the juvenile fish hide at high tide. They hide in those roots, so they're not getting eaten, and they can grow up to be the kind we like to eat. They also are really important in stabilizing the shoreline. They found Hurricane Wilma brought it really close to home, that the shorelines that had mangroves were still in place, and shorelines that had buildings were knocked over. So they're really essential for protecting. And I will say to you, they don't block the view, they are the view. 80% of our marine species depend on mangroves for some part of their lives. And so if we fragment and lose these mangrove forests, we're going to lose our fisheries. So here's a basic mangrove zonation. You have red mangroves that reach that growing furthest out, and then a little bit higher, and we're talking, centimeters in elevation. Then you have the black behind that and the white behind that. So they kind of zonate. And then behind them are the buttonwoods, and then once you get up too high, you have other vegetation. So knowing this, we know that mangrove forests only survive at certain water levels, at certain elevations of the shoreline. But as sea level rises, mangroves are going to have to move with the land elevation. As the sea levels come up, then the mangroves are going to have a place to go. And they are going to be dependent on sediments depositing behind them that they can grow into. They need the nutrients and they need the sea level. So they need open space behind them, not seawalls. And I can think of 3 developments going in right now that are going to prevent this from happening. This is a picture of a mangrove in St. Augustine. They don't grow that far north. So this was taken in 2013. There is a mangrove migration network. The United States Geological Survey is monitoring these sites in red on the northern Gulf to watch as mangroves comes in. And they're concerned that they're going to lose salt marshes because of mangroves coming in. And there's a whole different ecosystem going on with salt marshes. So it's really going to have impacts. So that's it in a nutshell. But we can do this. There are simple solutions. What can we do? Tell me what you would think of how we can counteract the rising temperatures, the heat trapping blanket. That's really easy. What do we do?
Ride a bike to the post office.
Right. Use alternative energy, right? Rather than creating carbon dioxide, we're using renewable energy resources. So that's the simplest thing. And that can be done. But all of these need to be done on a large scale. If just you ride your bike, it's not going to work. But if we all ride our bikes, then it will. Okay. Then there's also the mangrove issue. How can we fix that?
Stop permitting the destruction.
Stop what?
Permitting the destruction.
Permitting the, yes. So we can stop building in the coastal high hazard zone, which we're not supposed to do, but they keep adding variances to that. So the last thing is choose decision makers that are going to do this for our future and our children's future. So I'm going to try and get the video up. But any questions while I'm trying to do that?
I have a quick question.
Yeah.
How did people and companies like Mainsail over there on the island here, they're building that, the big hotel. When you used to drive north on Marina Drive, you couldn't see the bay. Now all of a sudden there's a clear view there of where their little marina, the boats are gonna go out. Did they have to apply someplace for permission to cut down what was ever in the way, or? did
Yes.
they wait and nobody
Yeah,
says
everybody
anything?
has to get permits
They
to
do
do
have to
it.
get a
Oh,
permit.
yeah. Yeah.
So basically what we have to do is lobby that these permits shouldn't be.
Correct.
permitted.
That's why I said
And
vote.
there was, the other one, what is the name of the one when you go over the Manatee Bridge from the island? Is it Harborville or something?
Yeah, the one on
All of
Manatee.
a sudden, it's like all the view of all
And
these
they-
buildings, and they just must have chopped off everything.
Well, no, the buildings are higher than the mangroves is the
Yeah, but
issue, but
this-
they did cut down
this
mangroves
view
as
I'm
well.
thinking of, you
And
couldn't see
there
it.
are some lawsuits going on that because they said that it was done without proper
Yeah,
permitting.
I bet.
So here we go. This is the
This is Bill Putnam.
Okay.
I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at
Leave it
is a
here.
supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean
so you
reservoirs.
see it's this is March. Those are the dates in the corner.
In the northern hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the northern hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade.
Yeah, so here we're in midsummer.
Meanwhile, in the southern hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world.
You can see they're burning in Africa.
As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS 5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.
All right. Thank you. So, questions? Yes.
The atmosphere is thinning, from what I understand, and there are spots like even over Australia where there are actually holes in the atmosphere. Is that?
Are you talking about the ozone layer?
Yes.
Okay, that's changed. That was from burning or releasing chlorofluorocarbons from aerosol cans, and we had huge issues in the 80s, 70s and 80s, but that's actually, we've stopped using chlorofluorocarbons, and that's actually reversing, where those holes are going away. So, yeah, it's a totally different thing.
Pertaining to mangroves, how hard is it to plant new mangroves?
Okay, so we don't even have to plant mangroves. Okay. If you have the correct elevation on the shoreline, they will recruit themselves. And we've actually found that the early 1990s, we planted Lefis Key area on Sarasota Bay, and we planted mangroves. And those mangroves that we planted as volunteers took a really long time to establish. But in the meantime, they just came in because there's such a great seed source, and they filled up. So they stopped planting, and they just create the proper shoreline, maybe put a few grasses in to hold the shoreline in place till the mangroves recruit. So all you need is that sediment deposition, and you're going to get mangroves in our area. So I don't know about other parts, but yeah. Yes?
Is there a way to mitigate the mangroves?
What do you mean?
Well, like a land exchange or an exchange?
Oh, mitigation banking like they have. So she asked if there's a way to mitigate for loss of mangroves. And not if it's not within our Bay Area. If we're losing mangroves and they're going to put them in, even in Tampa Bay, it's different. Then our system is our system. So mitigation only works within, and we are at a point, we've lost 44% of them. We can't lose anymore. So that's why the restoration projects that the Sarasota Bay Estuary provides are really unique in that, say, Lefis Key, what they did was they created a lagoon. They made that back into an island, and they've increased the mangrove shoreline by adding it behind the island. So in Perico Preserve, across, right up Manatee Avenue, they did the same thing. They created a lagoon, opened it up to Perico Bayou, and created an entire mangrove. That'll be a whole mangrove shoreline within that didn't exist before. So these are really exemplary projects where they're creating new mangrove shoreline and increasing our habitat. So that's really good. So it's making up for the 44% loss because it's new. But to answer your question, I don't think mitigation will work because there's no space anywhere within our bay to do it.
Sister Keys are a pretty good example.
Sister Keys are really good, yeah. Sister Keys was cleaned up. They removed exotic vegetation. So they were covered with, they were off a longboat in Sarasota Bay, and they were covered with Australian pine. And they removed those Australian pines. And then periodically efforts are to go back, we go back in and remove. I did one with the Sarasota Baywatch does a lot with Sister Keys. That's their project. So Yeah, and I also work with the Sarasota Bay Estuary Program. We have a Bay Guardians program where we have 6 events a year where people can sign up to volunteer, and we do cleanups and plantings and throughout the Sarasota Bay area in both Manatee and Sarasota counties. So that's a really good way to get involved, and I can get you contact information if you would like. So, any other? Yeah, very sustainable. And like you say, I don't know if you caught that, but they are filter feeders. So not only is it increasing the fisheries and the recreation, but they're cleaning the water.
So when you
Yeah.
put those in, they...
Well, an oyster will do 1 million gallons a day. Filter.
1 million gallons?
Yes,
An oyster.
an oyster. It's pretty awesome what those guys do. Yeah. So I'm sure clam is pretty close. Yeah. Yeah. Well, thank you, Ed, for giving us hope, because that's what a talk needs. A talk like this at the end needs hope. We get simple solutions, and that's an awesome one. So to summarize what Ed Childs just said is that we have all these fisheries, particularly the bivalves. The sunray Venus clam is, you have 4,000 acres potential. So 280,000 acres of shellfish, potential shellfish hatcheries available, potential. And we are doing less than 10% of that.
1%.
Well, less than 1% of that now. And our local sunray clam is a really up and coming potential seafood. There's a lot of, the bivalves are so amazing because they're filter feeders, so they're preventing, they're cleaning up the pollution, they're cleaning up the issues we have with water quality, and then they're providing recreational fisheries and commercial fisheries. So he compared that to growing tomatoes. That's our next tomato. Tomato's a big crop, but tomato is land-based monoculture and uses a lot of fertilizer and pesticides, where a bivalve fishery is going to be actually cleaning and providing value. So, hope for climate change. All right, thank you.